Broadcasting from Millennium Student Center at the University of Missouri, St. Louis, and online at umslradio.org. We are the voice of UMSL. We are UMSL Radio.
The opinions expressed on this program are the views of the host and not necessarily the views of the University of Missouri St. Louis or this station.
What's up, everybody? Welcome to another installment of That Science and Nature Show. I'm your host, Jeremy Howard, and joining me this week, as always, Microbe Master Webster Heffern.
Hi, everyone.
And we have a guest this week. Joining us as our guest, the man with the rockin' socks, George Todd.
Hi, everybody. Glad to be here again.
So, George, it's been quite a while since you've been on the show. The last episode you were on was Stories from the Field, which is like the season 1 finale of the show that we recorded over the summer of last year. But I want to have you give a little overview of who you are here at UMSL, if you wouldn't mind.
Yeah, absolutely. So I'm a third-year PhD student in biology here at UMSL in Professor Amy Dunlap's lab, and I am studying cognition and behavior in hoverflies, which are a very important but understudied insect pollinator group. And my background before getting here to UMSL involves lots of research in animal behavior, but also a number of years as an educator in biology. I worked at a technical college for 5 years and taught general biology and microbiology, and was a teaching assistant during my master's degree before that. And then I also TA'd 1 semester of anatomy and physiology here at UMSL before moving to a research assistantship. So I'm kind of taking a break from teaching right now, but I have a good amount of teaching experience, and I'm glad to be here on the episode about science education.
Nice. So I feel like since not many people know about hoverflies, what is a hoverfly?
So a hoverfly is an insect. It's a fly similar to a housefly. Most people call them sweat bees. So they tend to like to land on you for your sweat. And they're usually fairly small. And they are known for being mimics of bees and wasps, meaning they'll usually have yellow and black striped patterns that resemble bees and wasps. And this is a kind of mimicry for defensive purposes, but even though they look like bees and wasps, they are in fact flies, and they cannot sting. So that's kind of a very key distinction between them and bees and wasps.
Nice. Yes, they are very, I would not just say underappreciated pollinator, but just unknown pollinator, because people don't think about them.
Yes, bees tend to get all of the attention, and they're definitely the most important pollinating group, but there's a lot of research that's gone into different aspects of bee pollination. But hoverflies are probably the second most important pollinator group, but the amount of research that has been done on different aspects of their pollination is way lower than bees. So it's a gap that I'm hoping to fill with my dissertation here at UMSL.
Very cool. Well, we have a great show for you today. We're going to talk to you all about sinking cities in the news. We're going to talk about organ transplants potentially causing changes in personality. And we're going to talk about escape rooms, if you can believe it or not. It's going to be like a fun end of the news cycle today. Topic of the show this week, as George already alluded to, is going to be about science education. So what is it? Why is it important? How do we engage with it? What are problems and challenges of it? All of that good stuff. But diving right in. So we're going to start with our first story today. This is from Science Daily, and title of this article is 1/3 of China's urban population is at risk of the city sinking, according to new satellite data. So some individuals at the Tyndall Center for Climate Change Research, as well as Virginia Tech, basically have been looking at a lot of data with the satellites, looking at heavily urban areas, particularly in China, with lots of different cities. And they've basically found that just over the years, a lot of these cities are sort of sinking, but just very slowly. So they've shown that in areas looking at about 82 cities, they found that roughly 45% of these urban areas were analyzed as quote-unquote sinking, with 16% falling at a rate of about 10 millimeters a year or more. So that seems very minuscule if you were to read that, because 10 millimeters is a very small distance, but you add that up year over year over year over year, that's eventually going to compound to a lot of feet if we're in the U.S. using non-metric systems, that you'll start to notice things. And this is the problem, such as for coastal cities, because as we know with climate change, it is causing the sea levels to rise. So if the sea water goes up and the cities go down, that means more flooding. And that's a big problem for us in the cities. So what are our thoughts on just the idea of, and this isn't just applicable to China, this article centers on China, but this is happening all over the world. What is our thought about our cities sinking slowly?
I thought it was interesting that they highlighted that Shanghai had gone down more than 3 meters over the past century.
Yeah.
So that's like 30 millimeters a year. And they also mentioned that quite a number of these cities are going to technically be below sea level. So they're kind of at threat the same way New Orleans was a threat with Katrina. So I think it's going to be really interesting to see. We have a major urbanization of our population nowadays. A lot of people are moving to cities, and I think it'll be interesting to see, with cities going underwater, if people are going to start moving away from cities, what the population trends are going to be as a result of this.
Yeah, that's interesting. I did a little kind of additional reading, and so a lot of the cities in the United States on the East Coast are suffering from a similar problem, such as, for example, like Boston and New York City. And a lot of it just has to do with the immense weight of all of the man-made structures that are in that space, because in the urban areas, you run out of horizontal space very quickly, and so you build vertically, and that makes sense in terms of utilizing the space that's available effectively, but it's also, of course, creates a lot of weight that's kind of pushing the land beneath it down. And I think it's still is concerning. It's kind of hard to grasp probably for people living today, just because if it's occurring outside of our given lifetime, that's a common struggle for valuing or giving attention to concerns that last more than a lifetime, I guess. It's not just related to these urban cities on the coasts, but I also found out that Jakarta, the capital of Indonesia, has sunken at like one of the fastest rates like in the world.
Oh,
so
okay.
I didn't look more into it, but I'm curious if they've tried to like take any measures to try to mitigate that, or but I just don't know.
I wonder if the earthquakes have played into that, because I know Indonesia gets a lot of earthquakes, doesn't it?
Yeah, or tsunamis or
earthquakes.
earthquakes.
I think the earthquakes that cause the tsunamis.
Yeah.
The conjoined, I guess, effect.
Yeah.
Yeah, according to the article, again, back with talking about the cities in China, it seems like the big reason for these cities sinking is taking all this groundwater and using it, for drinking water and for other reasons, and that's sort of leading to this continued depression of the earth, because there's nothing really supporting all the buildings and things underneath. That's slowly draining everything out, and then the weight of the buildings that George described from all the development is slowly causing things to sink. The article cites an example in Japan, I believe it's Osaka. Yeah. In Osaka and Tokyo, they basically stopped doing groundwater withdrawal in the 1970s, and that kind of showed that slowly didn't totally stop the city from sinking, but it slowed things down considerably. Mm-hmm. It seems like it was kind of an attack to mitigate it, but the human element is still the problem, is that the development is ongoing and we're continuing to sort of slowly sink, though not realizing it.
It'd be interesting to see what would happen if you took that much groundwater and you didn't necessarily have the buildings on top of it. Do you get these sudden sinks where it's like you now evacuated a cavity and then suddenly the earth just falls? Or
yeah, I think about those freak stories where just someone is in a neighborhood and then just a hole just collapses.
Right.
What causes that? That's a scary reality to live in, but it's one we unfortunately do. All right, which I don't really have anything else to say on that, so I think we'll just move on to the next story. Oh, unless you had Webster.
Oh, I just want to mention, in China, it is really amazing, the sheer height of the cities. I've been to Lishan, which is one of the smaller cities there, and it's still just as tall as New York. It's phenomenal how tall these cities are, and these are solidly built structures. You go to Thailand, and it almost looks like everything's made out of paper. It looks like it's just going to just topple over. But you go to China, and the amount of development and the solidness of the development is really impressive.
It's interesting.
Yeah, definitely something that urban planners are going to need to keep an eye on in the pretty much for forever as we develop. But moving on, we're going to talk about an article from from Futurism.com, and this is called "Organ Transplants Can Change Personality and Even Sexual Orientation," scientists find. So some researchers at the University of Colorado basically followed up with a study involving 47 people who underwent, as you can imagine, a organ transplant where they, had to get a new liver or heart or what have you. They basically just mapped out sort of how they felt in terms of changes, in terms of preferences for things like food, intimacy, and any professional pursuits. And what they found, based on their discoveries, they said 6 of the 47 participants reported changes in quote-unquote sexual preferences. Some recipients reported they had taken on memories of their organ donors, so they're having like thoughts they think they shouldn't be having, whatever that means to that individual, as well as, what was the other thing? Some of them did also report from their organ transplant like negative effects, so they were like more depressed, they're more anxious, and potentially even sexual dysfunction. So, interesting phenomenon. The article has some critiques about what they're finding overall, but what are our thoughts on this?
I totally believe it. I've long believed that like when I learned to dance and I'm trying to learn choreography, I realized I'm actually like storing some of those memories in my body. I'm like having to tense a muscle in order to remember something. I'm using like an upside down reflex arc, where it's like I'm firing at that muscle. That muscle has some pattern in it that is then firing back at my brain, and that's helping my brain keep a thought going while I'm trying to learn choreography. And I sometimes have to turn those off because it gets in the way of doing the choreography, but it makes me more aware of the fact that I use those. And so I would not be surprised at all if our brains use these sorts of things with organs, where the patterning in the organ affects the reflex that comes back, and it's going to affect the structure of your memory or the structure of your sexual response. And so if you replace that organ with a different organ, it can totally affect this. On the other hand, I do also accept what the article is suggesting, that maybe some of these effects are just from health increases. Like you have a healthier body, it's going to be more sexually functional. You have a healthier body, maybe you're going to start activating memories and stuff that you forgot you had.
Did you have thoughts, George?
Yeah, I think I kind of automatically went to the more skeptical route even before reaching the part of the article that did talk about the critiques, and just because my initial reaction was to try to figure out what potential physiological mechanisms would be causing things like that, and not to say that the people were lying or being disingenuous, of course, but wondering what could be causing that in the tissues and in the cells and in the communication between the cells in the body. And then I got to thinking about how you could test that and realized that there were some pretty serious ethical dilemmas or roadblocks in testing that. So you could, for example, have a group of people that knowingly undergo an organ transplant and then have them do reporting like what this article did. But then you'd also have to have a group of people that you received an organ transplant unbeknownst to them, and then see if they report any like similar findings, give them the same test, and see if there's any changes in metrics of personality and all of that. But of course, it's not ethical to give someone an organ or force an organ transplant upon somebody without their consent. So that would not work.
That is a hard.
One thing you could look at, though, I mean, in particular the organs where they're associating it with memory changes, just look at how many temporal coding neurons and how many rate coding neurons tend to be coming away from these organs. How plausible is it that there could be some interesting pattern coming off of these organs that is actually going to affect cognition?
So wait, real quick, what do the neurons have to do with the organ transplant?
Oh, so I mean, every organ has neurons firing to it and neurons coming away from it. And there are different kinds of neurons. There's rate encoding neurons, and then there's the more complex temporal coding neurons. Rate coding neurons, it's like how intense the signal is going into the neuron affects how many fires the neuron does per second. Whereas the temporal coding neuron, it's like once you get past a certain threshold, then the neuron does one big fire. And the temporal coding neurons can help with things like timing. The rate coding neurons help with things like sensing temperature, like, oh my God, that's really hot. If you have a certain overlay of these, it might be better at encoding something like a memory. And if if you actually change the overlay of those or change the signal that's coming through those when you do the organ transplant, then it becomes plausible that, okay, a memory has shifted as a result of the organ transplant. But if you don't see that, I mean, so that you could look into some of the mechanism, I think, and actually analyze, are there physiological changes that make sense with what the patients are describing, in a way that wouldn't be quite as unethical as putting an organ in somebody without them knowing.
Right. The big thing that I was thinking about when I read this was just like, what kind of memories do they have? Because in a way, like, if you believe the claim that like they're saying is true, like what kind of things are you tapping into in someone else's life? Like, what do you remember about this liver transplant? Like, do you remember like a key moment in someone's life, or is it just like a random memory? My other thought from this was, what if you get like an organ transplant from like an animal? So like, for example, my dad had like open heart surgery like a decade ago, and he had to get the aorta replaced, and he replaced it with that of a cow. And I was reading this, I was like, what if he had like memories of like eating grass as a cow? Which sounds very silly and far-fetched, but I was like, well, if you connect the dots, it doesn't seem horribly implausible.
Yeah, what do cows remember? They probably do remember eating grass.
Yeah. I mean, maybe they have more complex thoughts than that, but that was just something my mind went to immediately.
Oh, and your dad probably likes vegetables more since that.
Yeah, maybe he's eating better. But that might also be like, hey, I had heart surgery. I should probably start eating better.
Perhaps, yeah. That adds a whole nother dimension I hadn't considered. That's interesting.
Yeah, the one thing I want to mention is that it was a small sample size. So it was 47 people overall, which just, as we talk about many times on this show, a small sample size. You want to have larger sample sizes to have more conclusive proof about whatever you're studying, just for any scientific study, regardless if it's, ecology, medicine, psychology, what have you. So it's always an important caveat to bring out for the audience. They also noted that the researchers basically may have had some selection bias because they were literally looking for individuals to participate in a study that was about examining personality following an organ transplant. So you knew what you were signing up for when you did this, which George and Webster already brought up. But I thought that was important to mention for the audience. Okay, now we're going to move on to our last article for the news, and this is from Atlas Obscura, and this is all about escape rooms. So title of this is World Competitive Escape Rooms Are Darker, Scarier, and More Scientific. So I think I'd just start out by asking, have either of you done an escape room before?
Yes, I've done 4 or 5 in my life.
Okay.
Oh, wow, that sounds fun. I've never done an escape room.
You've never done an escape room?
No.
Okay, I've done about 3 or 4 in the past decade, so like every so often. It's a little bit pricier of an activity as someone who's been a student, so it's not something I'm like, we're going to do one every week, but I definitely think is a unique experience. We should do an escape room as a grad students at some point. We'll make a little note about that.
That would be really fun.
Definitely.
I know we did that like, I want to say 2 years ago. The grad students, like one of my first or second year, I know the BGSA, I think, did an escape room.
Actually, we did one, and it was the one right by the river near downtown. I forget the name. If
I know exactly what you're talking about.
Are aware of that.
I don't remember. It's next to the Puzzles restaurant.
Yes.
Yes.
It's down the street from the restaurant.
Yes.
That has all the board games.
Right. We just don't know the name
We
of the
just don't remember the name. If
room.
any of our listeners know that.
It is next
We did go out to that one, and it was quite fun.
Yes. If you haven't done an escape room before, listeners, the idea is basically you're stuck in a room, but it's like you're there for fun. No one is trapping you there. And it's basically a giant puzzle box. So you have a bunch of clues to solve various puzzles to get you keys and solutions to move to either new rooms or to open up pieces of the room you're already in. And the goal is eventually, from solving all these puzzles, it's kind of in a chain sequence. Eventually you'll get a key to get out of the room. And generally the idea is like you're given like an hour or so, and you want to sort of beat the clock. So you want to see if you can get out of the room before the hour is up. I don't remember if they let you go all the way through if you don't, but generally it's kind of keep things moving for escape rooms. But yeah, you're kind of under the clock a little bit, and usually you try to do escape rooms with other people, because if it's just you by yourself, you're more likely to fail because there's a lot of puzzle aspects. So actually, let me back up. So escape rooms, like I mentioned, is kind of this fun entertainment thing that everyone does. But apparently there's a very serious global competition with this. There is an organization called the Top Escape Room Project Enthusiast Choice Awards, or TERPECA for short. And they're just really interested in seeing who can make the best escape room. And there's like a whole club/organization for this, where individuals have to have done, I believe, 100 to 200 escape rooms to kind of be a part of and be able to weigh in on what they think are better escape rooms. The article kind of mentions just the organization of itself, but also just that there's like some science that actually goes into making escape rooms. The big thing being what's called escape room theory, which I had not heard before. I mean, it seems somewhat straightforward because it's based on the thing that they're making. And the idea from this is that there's kind of rules you have as designing an escape room. It is basically a puzzle that you have your, game players partake in. So you want to make sure the rooms basically have puzzles that can be solved fairly quickly, are non-linear. So the idea being that like one thing doesn't necessarily, depending on how they design it, an answer to a puzzle or a key will like go to the room you're in, or potentially to another room, but that has to be sort of made explicitly clear as well. Additionally, you want to make sure that the participants kind of know what's in the room they can interact with or not interact with, because the big thing is if the player gets very frustrated and they don't know what to do, they're going to start trying to come up with creative solutions to potentially break things or do things they're not supposed to. So yeah, there's actually a lot of cool philosophy and psychology that goes into this. They break it down. One of the escape room experts, his name is Aurel Lumiere, boils it down, which is called like the escape room player loop, which is the idea that it's kind of broken into 7 sections. So identify gates, collect clues, select the gate to work on, solve puzzle, complete the puzzle, input the answer, repeat loop. So basically finding what you need to find, putting it in where it needs to go, getting the answer, and then you get sort of a reward as the player, and then you can kind of move on to the next thing. So George, of the escape rooms you have done, how many times were you successful?
I was successful in all of them, and so typically at a given escape room company they'll offer you a certain number of questions that you can ask, and then they'll give you something helpful to help you out, and that's been enough to get every group that I've gone with to an escape room to completion. There was one where we had literally 10 seconds to spare, and I had the last piece that had to be put in. Maybe it was a key for the actual door or something, and I was fumbling around with it and making everybody nervous because we looked and saw there's 10 seconds left. What are you doing? just open it up, and then I managed to get it open, but I did complete all of them. Yes.
I can just imagine you like shaking with the key, like trying to get it in the lock, and then like dropping the key.
Yeah, I just kind of took a quick breath and just was like, okay, I'm just gonna make this normal motion, and did it, and then we completed it. Yeah.
Nice. I think of the 3 or 4 I've done, I think we did one successfully. The other ones we got like really close, or like we were like maybe 3/4 of the way through, and then like we ran out of time. And it's some things it's just puzzles don't come together, or you get an object and you're like, I don't know what this is supposed to go to. It doesn't go to this thing. Okay, there's nothing else in the room I could think of to interact with. So some of the things the article describes as being frustrated, where like you hit dead ends and it's not very obvious where you need to go. I felt as the player being in the escape room. The article also mentions kind of a breakdown of sort of player types. So you can either be a diamond, a spade, a heart, or a club. So that kind of defines your personality for the escape room. So spades are people who really want to win. Hearts are those who really want to empathize and help other players. Clubs are those who want to like play against other people, so more that competitive aspect. And there's diamonds, or I messed up. And then spades, who basically want to look around for information. So like they're kind of the snoopy people. I definitely fall into the spade. I like being the person that like finds the clue that someone didn't look under this rug or whatever, and just try and find like things that maybe people didn't think about. What about you, George? What do you think you fall into? I'm fairly
exploratory, I would say, but I also kind of tend to just mess around for a little too long and have fun with the props that are in the room, which may or may not really be helping in the beginning. It's funny, I tend not to have as much urgency in the beginning, even though I know that there's just an hour or however much time to get it done.
That's how it always is, though. I'm the same, because you're like, we have so much time, and then as like it gets closer, you're like, we've only solved one puzzle. We only have 15 minutes left.
I've had people in my group then point out, what were you doing? Why were you doing all of that at the beginning? Like, it's not, yeah.
Yeah, you definitely want to feel useful. So it kind of seems like having each of those aspects is very helpful. It also helps with the more people you have, because more likely everyone's had, different experiences with things. So maybe someone's really good at like math and it helps with one puzzle, or maybe someone's really good with linguistics and that helps with another puzzle. So it helps having like a diverse group of people, and just generally you have more minds working on something, you solve problems faster. I think most of the time in the rooms that I failed, we didn't have the required number of people, and they're like, okay, we'll try it with 4, even though it's 6 recommended. So we'll see, and then it doesn't work out. So that doesn't surprise me too much on my end.
I was at one of them exploring and found this. I didn't know it, but it was one of our parties, the lady's purse, but I thought it was a prop in the room. And so I'm just like looking through her purse, looking for like clues and things and thinking like, oh, there's some valuable things in here. Interesting for them to leave that in here. And then the person I was with said, oh, that's my purse. What are you doing?
Like $100 bill.
Whoops.
Okay. Nice.
Sure, that's why you were going through it, George.
Yes. But yeah, the escape rooms based on the Tribeca organizations I talked about could get very complicated. Some of them are very even like horror or, very adrenaline junkie themed. I guess when you have more money to invest in the escape room, you can do that. But yeah, we definitely should do an escape room as the grad students at some point in the next few months. That would be a fun outing. But we're going to wrap up the news now. When we come back, we'll talk all about science education. Don't go anywhere.
Hey, Starlight. Book you on down to UMSL's Intergalactic Pride Disco. Pride Alliance is celebrating 30 years of jolly gay student solidarity with free dinner, dessert, and disco dancing for all UMSL students, faculty, and staff. Enjoy classic 70s and 80s ballroom disco hits at our sensory-friendly silent disco. Dance to your own beat with our synchronized wireless headphones that you can turn up or down to your liking. The Intergalactic Pride Disco is on Mercury, Thursday, April 25th from 6 to 8 p.m. in Century Room A. See you on the dance floor.
And we're back. And now it's time for Topic of the Show, where we talk about a pre-selected topic that I choose in advance. This week, we're going to be talking about science education and all about that. So, in some capacity, the three of us have been educators, whether we wanted to or not. And I think it's important for this topic to bring not only our expertise from what we've done as educators, teachers, et cetera, teaching assistants, but also just what we've sort of seen maybe growing up and learning about science. So maybe both from the teacher and the student aspect, I think will be helpful for this discussion. But I want to start out for the conversation. What is the purpose of science education? Obviously, we learned about science in school. We're studying science in PhD school. We clearly like science. Maybe not everyone does, but what's the purpose of learning about science?
When I think of science, I think of science as a process. And so science is the process by which we learn about the physical world and more broadly the universe. But most of us tend to study things like within planet Earth at all varying scales. And so science is the process by which we do that. And so I think for a lot of people, when they hear science, they tend to think of just information or facts, or when you're in school taking biology or chemistry or physics, there's a lot of learning vocabulary and terms and memorizing them and all of that. But I think what's more important to grasp and learn is how to do science effectively, because then you can take that skill and apply it to all sorts of different things in life, different kinds of careers. But even if you don't necessarily have a career or a job that's in some kind of science field, it's still a useful skill to be able to interpret science and scientific conclusions and have kind of scientific literacy would be the phrase.
Okay.
Yeah, I think literacy, for me, the two big things, if I were teaching somebody who didn't want to go into science, but I wanted them to have life skills from it, I'd say the literacy is huge. I want them to be able to understand what a vaccine is, how it works, why you should get one, and also the analytical skills that come from it. So not just how to set up an experiment were they ever to run into a scientific problem in the real world, but just understanding how to think about things logically in such a way that is scientifically sound. So if I have this set of facts and I have this set of questions, how can I conglomerate those facts to come up with the answers to the questions that are consistent with those facts?
Okay. So I'm trying to think of how I want to phrase this. How do you think science education and all the things both of you mentioned is different than just general education, just learning about stuff like math or English or history? Does that still apply to all those things, or is science unique in some regard?
I actually think there's more in common between history and science than we give credit. A lot of history is analyzing primary sources. You have this set of facts. You're supposed to come up with some cohesive story based on those facts. Science, we have the luxury with with the hard sciences of doing experiments actively in the here and now. But in terms of being different from those other subjects, I think one of the biggest things is probably that luxury of being able to do the experiments now. With math, you get to do the calculations now. Math is almost just detached from the physical world as this toolbox that we develop that can be applied to science. I don't know. What do you have to say on this, George?
Yeah, I guess that's tough for me to answer. I just go back to it being a process and being able to apply it to different things you encounter in life. And yeah, in some ways, sometimes other subjects are you just have to memorize or learn things. But while a lot of that can happen in science and is often necessary to provide foundational information, ultimately, I think the goal should be to develop the ability to do science effectively.
Okay. So as educators, again, in any role, instructor, TA, tutor, what have you, what kind of challenges have you faced in teaching science? Because this kind of applies to everything that you've talked about with what you want your students to get out of it, or just people in general versus the teaching side with what you're trying to get across to them.
I think one of the biggest challenges I ran into as a TA, the class that I taught the most was Intro to Biology. I can't remember the exact course number right now because it was a year ago. But I taught this class for, I guess, about 2 years, and from maybe 2.5. And for me, the biggest challenge was when the students didn't have the correct math background to be able to analyze the problems. Okay. So they need to do a pH. It's on a log scale, for instance. Dr. Rowland was very good about making sure they understood the log scale very well, even had to memorize some values from that. But for them even to grasp those concepts, there's a little bit of math background that you need for that. And some of them just were confused, blanking on that because they didn't necessarily have that math background. So if they didn't have almost the required math background or required other background that they needed to do the immediate science, that was one of the biggest challenges, because now you have to teach them that in addition to teaching them the topic that you're at hand.
Okay. Yeah, I have something or similar thoughts. I've taught over the years in my master's program and here, I've taught intro bio. These are lab courses mostly. Intro bio, human A&P, vertebrate anatomy, physiology, animal behavior, ecology, so on and so forth. So the biggest thing I think of late that I've noticed with animal behavior lab is it's very research based, because the kids have, I can say kids, my students, in a way they are my children. But the biggest problem I have is that they don't have a lot of the skills, like you mentioned, Webster. In this case, it's not so much mathematics, it's more like data visualization, like at this point, because they're upper level undergrad. It's like, okay, you haven't made a graph before, or you haven't found a primary source that we talked about with like scientific literature or historical literature, as you mentioned, and just getting them to where they need to be for that. And a lot of times it's, you wonder if they just didn't pick it up the first time they got it, or they did the thing, and I am guilty of this as an undergrad, is I dodged the hard courses I didn't want to take because they were going to add more anguish to me and more stress. So I knew this professor taught this, and they're not very well liked by the undergrad students, sort of the gossip you hear. So I'm going to avoid this course and take this easier form of it, and then when I get to this other course, it actually bites me in the butt because I didn't take the harder course that would have gotten me the skills to, you know, benefit me later in this upper level course. So I have to kind of do, like, in the first week of class, like a crash course and like all of these things that I think they should have known by this point, but they don't, and then get them up to speed to where I need them to be. So that's always been my challenge.
Yeah, I think I've shared in that to some extent, and the issue of if a student's taking a course just because they have to get the degree or to get to whatever milestone, and so I actually used to teach dual enrollment high school students in my previous job, and so they technically didn't have to be in my course because they were had other science courses they could take.
Oh, so they liked you. They wanted to be in your class.
So that's the theory anyway. But a lot of them, their parents kind of really wanted them to be getting ahead and getting college credit while still in high school, or the school counselor just kind of, they would let their school counselor just kind of recommend what they should do and then just kind of take their word for it without really any much personal thought on the matter.
Yeah.
And so I'd still, a lot of my students would just kind of be in my class and just kind of take the approach of what's kind of the minimal amount of work I can do to slide by with whatever grade I think will be fine for my GPA, or let me graduate. And so sometimes that can be a hindrance in challenging the students to really grasp the concepts and how to apply them.
Do you take offense to that? This is just to both of you. If your students are like, I'm just here to get this credit to pass this course. Because, I mean, let's be honest, we've all taken classes that we didn't enjoy, that we didn't just check this box. And I'm not even talking about science. I'm talking about across the board, math, English, history, whatever in whatever in high school or college. And it's like, okay, I just need to get through this, but I'm probably not going to use this, for my job, for my career, whatever. So I'm just curious, is that mentality on when someone comes to you, and they don't necessarily have to say this directly to you, but maybe the way they're acting or, the level of effort they're putting in, does that bother you as, their science instructor? Because we could make and I'm playing devil's advocate here, we could make the argument of like, we went to like a humanities class, we're like, well, we're not going to use this. Why should we try that hard? We should just check the box or do the bare minimum. So I'm just curious about your perspectives on that.
Well, first of all, I did totally do that in my Spanish class in college. It was just a check the box class, and the teacher was furious at me, and I don't blame her. I think it's particularly bad in collaborative classes, like lab classes, because you've got one or two kids in the lab group that are trying really hard, and that one kid who just doesn't care because they're there to check the box. This is a requirement for them to graduate. They're never going to use this again, or so they think. And they're just sitting there doodling on their phone, doing whatever, not grasping the concepts, copying the other students' work and not really processing it. That comes exam time, they have no idea what's going on. That is really frustrating because it seems like it can hold the other students back, and it's almost like the class would run more smoothly if that student weren't even present, and I hate that feeling.
Yeah, I will echo that, Webster. I did that myself with a number of classes that I took when I was a student, and I can actually say I know for a fact that some of my students had that feeling because, and again, in my previous job, at the beginning of each course, every year, I would actually pass out note cards to all of my students and have them put their name on it and then write the reason they were taking the course on the note card.
Okay.
So that way the information wasn't shared with their peers.
Yeah.
But I would tell them, you're not going to offend me if you literally just write, I'm taking this because my parents wanted me to, or I'm taking it because the counselor said it, I should, or I feel like I need to for whatever reason, but I'm not really that interested in the course. I told them up front, I'm not going to be offended if you say that, and it's not going to affect your grade at all. And in fact, I would get a lot of students that would write on the note cards things to that effect. So
okay.
I can say with confidence because I would get that information in writing from them.
Okay.
Just out of curiosity.
Okay.
Yeah.
Interesting.
Would you find that the ones who would answer that way would be slower in the class?
Honestly, not really. There wasn't always a clear correlation.
Okay.
Really. Yeah.
So I think the thing that you need to also bring up is that science is very hard. It's very challenging. We're PhD students, and it makes it, from the outside perspective, a lot of people think that we're like rock stars in science. Like, we're so good at it, and we excel constantly, and like we just did so well in our undergrad and previous grad school if we did a master's, that now we're doing a PhD because it's just up. But it's always a struggle, and science is very challenging. And for a lot of people learning about science the first time, this causes a lot of problems because they get frustrated, and when people get frustrated, they want to stop doing the thing that is making them frustrated. So I'm just curious about, in your experience doing science education, and this is at any level again, so wherever you've taught, have you had students be frustrated? How have you dealt with that? are there ways to make science more interesting to learn about so they're less frustrated? Did you even care to help the people that are frustrated? And I don't mean that in a callous sort of way. I'm just saying, like, maybe you didn't feel it was your responsibility to do that, and that's just sort of on the onus of the student, because part of just learning about being a student is establishing grit and just like being able to kind of dust yourself off when something goes bad. And different people have different levels of grit, so I'm just curious on your thoughts on this.
Yeah, so I'll start off by saying that education really is a two-way street. So there's a student teacher professional relationship there, and so there's generally expectations on the student to be willing to put in work and things like that. But then there's also expectations for the teacher to put in work, and so for both of them to the best of their ability, learn and teach. But I think there are a lot of things that educators can do to maximize their effectiveness, and that's one big thing that I've grown in here at UMSL. And the reason for that specifically is because I have been a part of the CUT program, and that's the Certificate in University Teaching that UMSL offers through the Center for Teaching and Learning. And it's a series of modules that are designed to help people that are either already educators or are prospective educators build valuable teaching skills, professional skills, learning how to teach with different kinds of technology, learn how to implement active learning. And especially the active learning component, that's something I really have not done a good job implementing myself in my previous teaching experiences.
Real quick, what's active learning?
So active learning contrasts with passive learning. So I'll kind of describe passive learning first. So passive learning is basically you have students in a room with the teacher, and the teacher is basically just spouting out information, and usually this often manifests in a typical like lecture hall setting where there's a teacher with a PowerPoint and they're just kind of going through slide after slide after slide.
Sometimes reading verbatim off the slide.
Yeah. And even if you're just doing that, there's different degrees to which makes that better or worse in and of itself. But even if you're still doing some form of that, and that's really all that you're doing, that's kind of just the students are sitting there passively trying to listen and take notes, but that's all that they're doing the entire time. And so active learning doesn't do away with that entirely, but does much less of it because other sections of time in a given class are taken up by doing group activities, or what's called think, pair, shares. And it's designed to get students interacting with one another to help them understand concepts. So it's not just the teacher spouting out information about things. It's the students who will help each other and gain confidence because they'll hear what other students are learning and how they're processing the information. And so there's a lot of research that's gone into continues to show that tends to be more of an effective means of helping students grasp and apply concepts in any kind of subject. Okay. Not just science. And so I'm hoping to implement more active learning in my future teaching career. Yeah,
active learning is also called flipped classroom, yes? Or is that different? I know what both of these things are, but are they the same?
that phrase can be used kind of interchangeably with that, yeah.
Flipped classroom, listeners, is basically when the students, I'm thinking of this as like a teacher being the presenter, the students being the audience, like passive learning. But the idea where the students kind of take charge of the learning themselves, which sounds very redundant for the definition, but instead of the teacher standing up there in the PowerPoint and like spieling off information to the students and them taking notes, the students will like read something in advance and then come and discuss it. So they're kind of bringing the ideas to the table and the things that they don't understand or what they do understand and need more clarification on, so on and so forth. The idea is kind of putting the ball in their court so they take ownership of their learning, which I will admit I've been on the flipped classroom side and I don't always like it, especially when I don't understand it, because I kind of like, admittedly, I kind of do like the passive learning. Like the instructor is passing their wisdom to me, and I am, absorbing it and then, regurgitating it on the exam. But it's nice to kind of have that, like, what's the word I'm looking for? that almost like authority figure on the subject for like a professor in college being like, okay, this person is giving me information and I know they're right because they're the prof, versus, you know, flip classroom, it's like, I read this, but I didn't really understand it. And I don't know if my lab mate did or my other student, but I guess that's kind of part of the point is you're supposed to work together to, you know, piece it together.
So for things like our graduate seminars where each week it's a different presenter, does that qualify as flipped classroom?
Yes, I would think so.
So in at least the seminars in our department here at biology department here at UMSL, I think the entire class structure is different because it's more of just a discussion format. There's someone who's walking through a paper and then leading the discussion, but the class structure is mostly discussion based. It's not like the presenter each week is responsible for teaching concepts that the other students are then going to like take an exam on. And so I think it's kind of a different structure, but the active learning I think applies mostly to where there's a teacher that's going to be giving out assessments of some kind that the students will receive grades on directly.
Okay.
Mm-hmm. Yeah, back to the idea of science being hard. I'm kind of really in the camp of, and there was a supplementary article that I just want to bring up really quick. This is from LinkedIn. And it's basically talking about I'm going to botch it. I always botch the word. It's like a hybrid word. It's edutainment, which is a combination of education and entertainment. So edutainment in STEM and basically how entertainment can kind of help with education. And the article is pretty short. It just talks about for, you know, STEM, science, technology, engineering, math, getting more interactive ways for students to learn about concepts. So they talk about video games, which is like coding and mathematics applications, as well as like VR and some allusions to more active hands-on learning with students. But I'm really a big proponent of just having students kind of enjoy what they're learning about, which for me, I have a little bit of a theater background. So I did theater for 4 years in high school and then like some kind of side projects as well, like when I was in college. And I just really like the aspect of like performing. And I think if people can kind of enjoy what they're consuming as like content, and I know this is getting really like influencer based, they'll be more likely to, you know, engage with it or take something away from it. Like when we did the zoo episode last week, when we had John on, we talked about people not going to zoos to be educated, to be entertained, but while they're being entertained, they can actually pick up information they didn't think they would and walk away from the zoo actually more educated despite that. So I was kind of thinking about it from like that angle. So like, how can we kind of make learning fun? It sounds like such a cliche thing, but that's kind of where I approach it. However, I realize that for some things that's not always possible. So for like rudimentary science, so like your intro bios and your basic A&P, there is just a lot of like memorization and vocab. You kind of have to just learn like a base level to, you know, kind of be able to do the other things. So this is where things get conflicted and muddy in my mind.
Yeah, and I think one of the issues with the edutainment, if you think about the people going to the zoo, how many hours do they spend at that zoo to learn how much information?
Right.
Like we don't necessarily have the time during a normal class period. If we have to cover this much information, this much content. Can we really entertain throughout the entire process and cover all of it?
Right. There has to be a level of like rigor and I guess stringency to it. The thing we haven't really talked about much is science education obviously applies to primary school, so elementary, middle, high. One challenge that a lot of science educators just reading up and prepping for the show is that they have to teach you the tests. So they have an exam at the end of the year where there's like some sort of high school assessment or the AP exam or whatever, and they have to like check all these boxes and hit all these marks. So, you know, as part of the school curriculum, they've hit these points, so it doesn't really matter per se, you know, I'm trying to think how to say this. They're trying to get through all the content because the school board will be mad if they don't. And the problem is that some students learn things better than others, and there's different learning levels and so on and so forth. Some people are disengaged with science, so then that creates a whole host of problems. So I don't really know where I was going with that. I was just making a statement about how science can be challenging at the primary level. Because we're, you know, at the collegiate level, so people kind of generally want to be here for the most part, I would think. Unless, like people on the index cards that George talked about wrote, my parents are making me take this class. So
yeah, and I think looking at it from an entertainment perspective can be distracting a lot of times because so you have some kind of goal that you're taking a course, or if you're majoring in something if you're in college. You have some sort of goal. The goal is to get the degree and hopefully to be able to gain knowledge and learn skills and things in the process. And so I think the degree to which aspects of that during that time work towards achieving that goal can be entertaining, I think that that's great, but I think I would lean more towards the side of that. I don't think students should have an expectation for things in class to be entertaining on any sort of regular basis. And perhaps for a lot of younger grades, you can incorporate a lot more entertaining ways to learn. I think about a lot of like children's museums, for example, a lot of things are set up in a specific way for kids to be able to interact and to touch and to play some sort of like game or be competitive or something like that, in that I think is more useful for younger people, for kids, but then it kind of veers away from that more.
Yeah, I think for science, like entertainment or edutainment, I gotta really think about that word. I agree with what George you're saying, where I think it helps with like younger kids, where you're trying to kind of spur that natural curiosity and they want to know more about the world and more about nature or chemistry or physics or what have you. I think though it also has a place for like people who didn't major in science, so just like we talked about at the zoo, people who come to the zoo and just like learn about something about the animals, and that helps with like conservation stuff long term. I do agree though, like at some point you kind of have to get down to brass tacks, but the hard part, like I mentioned before, is that science is really hard, and then when you get down to brass tacks, people fail and become disengaged, and like how they get back up from that. I don't even know if I have a question for this. My thought is just like, how do we make people more gritty like and want to learn about science?
Well, actually, back to the edutainment point though, there is one thing that we could do with our science, like especially with the lab classes, and I think Professor Wollen's pretty good about this. The labs tend to be very colorful. So
like literally?
Yeah.
Okay.
Yeah. So like for instance, the photosynthesis lab, they're running all these different color pigments out on, and they're seeing it all spread out, and it makes this beautiful thing. And then also in that lab, we have a color changing pH indicator. They're not just using pH strips to evaluate the pH. They actually have a color changing pH indicator. So I think the more color you can add to what they're doing, the more just intuitively entertaining it is without it being like blatantly, oh, we're playing a game. That sort of stuff you can bring into the science education without detracting from what they're learning.
Okay.
Yeah, all of this reminds me of Bill Nye and all the episodes of Bill Nye the Science Guy. And there are many kids in school that, for whatever reason or another, if there was a substitute or if the teacher just wanted to do it, they'd roll in the big cart that had the box TV sitting at the top and get the Bill Nye VHS tape out, and everybody in the class would be like, oh yes, and I'm sure some students are like, oh okay, there's an opportunity to sleep, because they're just watching a video, but some students might be like, oh sweet, we get to watch a Bill Nye episode. This is great.
But that's great edutainment though. Like that's like, because Bill Nye was very zany and goofy, but like also you did learn some stuff from Bill Nye. So again, I don't like I understand that like you can't always do entertainment for science, but I think it has its place, and I think everyone can't just dismiss it and be like, we have to like just be hard and rigorous for science all the time. But again, like I don't know how you build people to be gritty. That's like a broader education challenge in general. Like how do you make students learn how to fail and get back up?
Yeah, actually, I remember I had a really tough time getting one student. I was like, in order to learn this right, you just have to drill it. You have to go home and you have to drill it. And he's like, well, can you give me any extra credit for drilling it? I was like, unfortunately, I can't.
No.
The credit is when you do well on the exam.
Yeah.
Yeah, I think that I don't think the grittiness is really the responsibility of educators. Honestly, I think that's more on the individual and their upbringing or background.
I mean, maybe, but I feel like we have to champion it a little bit. Like we have to, encourage them to want to try. I mean, I get that like it can't be all on the teacher, because at the end of the day, the student has to want it more than we do. Like they have to want to succeed more than we want them to succeed, because they have to put in the hours to study or learn the concepts or do the lab reports or write the papers.
Yeah, I think you can encourage students to be gritty and explain that you're going to have to be really be disciplined to do well in this course or to grasp this or that concept. I think you certainly should encourage them and offer assistance and be there. But yeah, ultimately when it does come down to it, it's like the saying about the horse: you can bring a horse to water, but you can't make it drink.
I also think just in general, and this is someone who was very type A in school, not obsessing over grades and more focused on learning concepts. But that's really hard because our society is so structured in grades and like achievement being based on grades, getting into programs, schools, future careers, whatever. Mm-hmm. So these are like bigger problems in science education that kind of bleed into it. But yeah. I'm going to wrap up this conversation with one final question. Just moving forward, just beyond, right now in PhD school, do you want to continue with science education? And if so, in what capacity? Doesn't have to be like formal, I will be a professor so-and-so, and I will teach class so-and-so. Like, just, do you have any interest in doing this?
If I were to go into academia, I think I would like to do this. I don't necessarily anticipate going into academia. I might be more prone to go into industry at some point. But actually, I've seen people in industry come back and teach. And I was like, that looks like a lot of fun. The advanced molecular biology class here was taught by a guy from industry, and he just came back and he was teaching in the evenings after he was done doing his job at Millipore Sigma. I was like, that looks like fun what he's doing. He's actually getting to engage with people after all day not engaging with people. So I could see it.
Okay.
So my goal actually is to be get a teaching focused position in higher education. And I never had the goal growing up to be a teacher. And my mom is a career teacher, and she would always joke with me and say like, oh, I could see you being a really good teacher one day. And I'd just kind of like laugh at her like, yeah, right. Okay, whatever. And guess she got guess she got the last laugh there because I did end up becoming a teacher, and was a TA and then taught full time for 5 years. And my goal after getting this PhD is to work at a college or university, primarily in a teaching capacity. But one of my goals is also to be able to mentor undergraduate students in research experiences. A big reason for that is because of my own personal experience as an undergraduate, in that I had a number of professors that it was very clear that teaching was not their passion, not their interest. And they were doing it simply because that was in their job description, and they were really just interested in doing research. Yeah. And I and a number of my peers were really negatively affected by that. And I'm not gonna sit here and say I was the perfect student and always, worked 110% to get straight A's or anything like that. But knowing what I know now, having been a teacher and remembering back to like how they taught and what they did or didn't do, it really is kind of disappointing to think about. And so that's provided me motivation to really be the opposite of that for undergraduates that I will end up teaching once I graduate here.
I've heard from professors I talked to in my master's program, sometimes learning who your anti-role models are can be just as valuable as learning who your role models are. And I was like, oh, that's like super wise wisdom. Because I just think about not just professors, but other people who I've met in my life. I'm like, you are someone who I do not want to be like, or like I want to be the exact opposite so people don't fear or loathe you or whatever, whether that's in any kind of teaching role or, role of power or responsibility. Just I think about like the anti-role model people, like those have been weirdly somehow more teachable or more important or equally as important, depending on the case, than like people who I admire and I want to be like. So it's weird that like that kind of works into. But for me, I'd say I'm kind of in two camps. Like I could see me doing teaching stuff, but I'd be more like you, George, where like I'm not really that interested in doing research. Like I would not be like a faculty member here. Like I could not handle the research pressure of that. And honestly, the farther I go in, I'm like, I don't think this research thing is for me. But I kind of also like really interested in like scientific communication and outreach potentially for a career. So like that's why I bring up like the edutainment thing, where like how can we make science more accessible if it's more entertaining, but you can still get little like nuggets of information across. How do you do that, and where do you get the skills to do that and all that? So that I find fascinating from kind of a presentation standpoint, but also, kind of using what I know and how do I break that down, kind of pulling from not just, what we do on this podcast, for example, but also just like teaching, like the lessons I've learned with working with people who don't understand concepts or have to get them up to a certain point to learn something, at various levels of where they are in their education career. Maybe they're not educated at all. Maybe they have some, high school experience in science. Maybe they have, a large amount of bachelor's degree experience in undergrad, what have you. So that's kind of where I'm coming from that. But that's all the time we have for this segment. So we're going to take another quick break, and we will be back with Outside of Science. Stay tuned.
Howdy, folks. My name is Carson Howe. As a transfer student, I know the pride of UMSL is our student community. It's always been diverse, active, and welcoming to all. However, in the years after the pandemic, our Student Government Association has not been supporting our community to its fullest. As your student government president, alongside my colleagues in Triton Renewal, we will change that. Through servant leadership, we will connect and rebuild our community by bringing student voices back into the decision-making process and redesigning student government to focus on who matters most. You. So this Mirth Week, April 22nd through April 26th, vote in our UMSL SGA elections and vote for Triton Renewal. Carson Howe, Allie Davis, and Grace Desjardins. Go Tritons!
And we're back. And now it's time for Outside of Science, that segment where we talk about, you guessed it, things outside of science to prove that we are in fact not robots that do research and work 24/7. So, what have we been up to in the last week? I know much like last week, we are barreling towards the end of the semester. This is the last week of classes, and things are very chaotic, as they always are. But have we had time to do anything interesting to talk about?
I haven't done anything interesting yet, but I started to schedule a trip for 4th of July weekend, which I'm really excited about. We're going to be going to the American Southwest, or I should say the U.S. of American Southwest. I'm not sure exactly which areas, but I want to see Canyonlands, and we're going to have a 6-day trip. So figuring a lot of that out tonight and over the next week. I'm excited.
That's cool. Nice. How about you, George?
Well, one of the big things that I do outside of my big things I do outside of my academic life is music. So I actually am a trombonist, and UMSL does, in fact, of course, have a music department, and
Thank
for
God.
the larger,
you gotta balance the science out with something.
Oh yeah, for the larger ensembles, and in some other instances, they do let non-music majors as well as community members play in the ensembles to fill them out and make sure that they can exist and that the music majors have the opportunity to play in those larger groups like an orchestra or a wind symphony. And so last spring I started playing in a couple different UMSL groups, the wind symphony and the jazz combo. And so that's been a lot of fun. I've gotten to do some concerts at the Two Hill Performing Arts Center and a couple other places, and so that's been really fun. Looking forward to the summer, though. I will actually be going with my dad and some of his friends up to Canada on a fishing trip.
Ooh.
And so my dad and I have been doing this together since 2007, roughly every other year or every 3 years or so.
Even with COVID?
And, no.
Okay.
No. But my dad has been going since at some point in the 90s, and then one of his friends that kind of started this tradition has been going since the 80s. So it's been going on for quite a while. And we basically go up to, usually it's near Kenora, Ontario, and we take a water plane that can take off and land in water, and we fly out to a remote lake in the middle of the nowhere that has a cabin, and we just kind of fish on the lake, and we have the whole lake to ourselves kind of for 5-6 days.
Nice.
And get to eat fresh fish every night, and just kind of have fun and get away from civilization. And it's just very serene and very beautiful. No light pollution at night. It's very, very amazing, and you get to see a lot of cool wildlife, bald eagles, moose, a lot of small mammals, and so it's a lot of fun, and I'm looking forward to it.
Nice. What have I been up to? So the big thing is last week, my friend Brandon, who you actually met at Webster, he was on the Wetland episode. He's the guy that works in Texas Tech. He had a bonfire to his place, and he invited me and some other friends that I have from my master's program at SAUE. So we hung out because I hadn't seen some of them in a couple of months. So that was nice. We just hung out. He barbecued some, I think it was bratwurst. I don't remember what it was. It was something meat related. Anyway, we just hung out and talked, and it was a nice little chill evening, which I desperately needed because definitely been very wound up and feeling the burnout, unfortunately, from the grad school life, as it were, as I'm sure many grad students have felt in the past. So yeah, that was much needed respite. But yeah, any last things before I wrap up the show?
No, thanks so much for having me as a guest on this episode. I always love talking about science education.
Yeah, of
thanks
course.
for joining us.
Yeah. All right, I'll do the ending spiel as I usually do. So thank you so much for listening to That Science and Nature Show this week. As always, thank you to Webster for joining me. Becky was not here this week, unfortunately. She had to prepare for a committee meeting, which she's going to nail tomorrow, but she'll be back next week with her last episode of the semester. Can you believe it, Webster? We've made it an entire semester again.
It's sad for me because it might be my last episode ever because I'm going to graduate probably at the end of the summer. We'll see.
Okay, well, I hope you so, because I, want success for you and to
Yes.
graduate and all that. But we might have some summer content coming as well.
Oh,
so stay tuned for that. I'll talk more about that next week. Thank you, of course, to you, George, for coming on. I know we just said this a second ago, but it was awesome to have you. Feel free to come back anytime because we love having you on the show.
Thanks. Yeah.
Remember, you can find past episodes of the show on Spotify and Amazon. Next week is our last show of the semester, but come back next week so you can hear my voice and Becky and Webster's and our guest, and we're going to talk about a lot of fun science stuff next week. Until then, my name is Jeremy Howard. You've been listening to That Science Nature Show, and we are out.